Welcome. This is Bill Curtis, the Executive Director of the Consortium for Information and Software Quality. And today I'm going to tell you about a new ISO standard that was approved at the end of March called the Automated Source Code Quality Measures. It was a publicly available standard submitted to ISO by the Object Management Group as a result of a specification developed by the software experts at the Consortium for Information and Software Quality. Let's see, here we go. So this standard lists 4 measures concerning the internal structural quality of software. These 4 measures are reliability, security, performance, efficiency, and maintainability. I'm going to show you how these measures are constructed, what they're constructed of, give you some ideas about how they can be used. But these are calculated from detecting weaknesses in the software itself, severe architectural and coding weaknesses that we can detect using static analysis technology, and count and create a measure of the structural integrity of the software in any one of these 4 areas: reliability, security, performance, efficiency, or maintainability. In essence, being able to detect these structural weaknesses early allows us to shift the quality work on the internal structure of a piece of software left into the development phase, so we don't have to wait until we have a problem in operations. This allows us to detect the kinds of structural weaknesses that will cause these problems much earlier than otherwise would have been possible. There's several different ways to use these measures. They can be used for internal product improvement, to improve the product before it goes into operation or before a new release is put into operation. It can also be used to evaluate how effectively your process is working in terms of avoiding large, severe internal quality problems in the product itself. These can be placed in contracts with vendors and third parties and contractors to say this, these are thresholds of quality you must achieve in one or all of these 4 areas, and we will be using these as acceptance criteria when we receive the software from you in order to be able to determine if it's met the agreement we had in the contract for the level of quality that you'll achieve in building this piece of software or in maintaining this piece of software. So this was developed by the Consortium of Information and Software Quality. It was fast-tracked to ISO. CISC is a special interest group of the managed by the Object Management Group. It was jointly created by the Software Engineering Institute under the direction of Paul Nielsen and the Object Management Group under the leadership of Richard Soley. They got together and said, we're hearing a strong need for international standards to measure these characteristics of software, things like reliability and security, because a lot of the system integrators were going to them and saying, we're seeing these in our contracts, or writing security or reliability or maintainability into our contracts, but none of our customers agree on how that's defined. We need international standards. And so that's the genesis of the consortium, was to really be chartered to build automated measures, specifications for automated measures of size and software quality that can be used to evaluate a large software application. We have a number of sponsors and we have a number of partners that we work with to help deploy the standards, and you can see them there on the screen. The sponsors provide the funds that allow us to operate, that allow us to maintain the website, to host our annual cybersecurity conference in Washington, D.C. We also have hosted them in Europe as well as in India. So this is the work that we've done. This was the consortium was formed in 2010. Since then, we've produced both size and quality standards. You can see the two size standards here. Automated function points became very popular. In fact, it was submitted under a publicly available standard to ISO and was approved by ISO as a standard. There's a number of function point standards that ISO has approved. This is the one that talks about automating function points according to the definitions used by the International Function Point Users Group in their counting guidelines. But that doesn't account for the non-functional part of code, and we kept seeing people struggle with that. So to be able to account for non-functional sizing when they were engaged in a enhancement or a piece of maintenance that did not involve the functional aspects of code. So we created automated enhancement points, which integrated function points as well as the measurement of non-functional software. On the quality side, we originally started with these four measures: reliability, security, maintainability, and performance efficiency. We later built a measure of technical debt that looks at the effort to fix weaknesses in those four areas, and we've since added one for data protection, which is relevant to things like HIPAA and healthcare and GDPR and in the European Union and the California Privacy Protection Act and other sorts of areas that require protection of confidential data. The original four quality measures, reliability, security, maintainability, and performance efficiency, were defined for IT applications, for business applications. We then upgraded those to also measure weaknesses in embedded software, and we combined all four measures, all four upgraded measures, into a standard called automated source code quality measures. That was submitted as a publicly available standard to ISO, and on March 30th it was approved as ISO IEC 5055. So that is now, those measures are now an international standard, and that's what I'm going to describe to you for the remainder of the webinar. We define those four measures very carefully from the ISO 25010 standard. That's the ISO standard that deals with software product quality. It defines 8 characteristics of product quality, 4 of which were incorporated into our automated measures. So we use the sub-characteristics of these 4 measures as a way to make sure we had covered all of the aspects of those quality characteristics that could actually be measured in the source code. So we are consistent and conformant to ISO 25010. ISO 25023 is the standard that defines measures for the actual quality characteristics. Most of the measures in 25023 describe the operational behavior under these 4 quality characteristics. So for instance, you see in reliability, availability, that would be measured by uptime or downtime. It wouldn't be measured by things like improper synchronization within the software or improper error handling in the software or other things that would cause the software to crash or be difficult to recover. So the security measure in 25023 would look at the number of breaches and how they were repelled, whereas the security measure for ISO 5055 would look at things like SQL injection opportunities and cross-site scripting and buffer overflows and the things that hackers exploit in the code to break in and steal confidential information. So 5055 supplements ISO 25023 by creating internal measures of the software product itself that relate to these 4 quality characteristics. This is how the 5055 standard is constructed. These 4 measures are built from detecting weaknesses in the software, and when we began the work on building these standards, we decided we would only incorporate weaknesses that we knew to be severe. In essence, they're weaknesses you know you need to remove from the software. If it's a weakness that you can defer forever and someday maybe we'll fix it, but it's not important if we don't, then it's not included in these measures. These are only severe weaknesses. You can see that you can see here we have the concept of parent weaknesses and contributing weaknesses, and that's because these are all represented in the common weakness enumeration, which identifies a parent weakness which may have some contributing weakness under it. For instance, if you look at the security measure here at the top, you'll see that one of the examples of a weakness that we would incorporate into that security measure is a buffer overflow. Now, there's many ways a buffer overflow can happen. In fact, there's 13 different ways that buffer overflows are defined in the common weakness enumeration, 13 different uh, instances. And so those are listed as contributing weaknesses under the parent of buffer overflow. So that's how we construct these parents and contributing weaknesses. The contributing weaknesses are really instances of a parent weakness. But you can see then, count those up, you can see that there's well over 100 different weaknesses that are incorporated into these. Some weaknesses, for instance, buffer overflows, would be in more than one of our quality characteristics. So a buffer overflow appears not only in security, but also in reliability, because it can cause reliability problems as well. So there's 138 unique weaknesses, some of which may appear in several different quality characteristics. So you can see that these were built by an international team of experts working with CISC. We had meetings in the U.S. and Europe and India where people would get together and start putting together lists of weaknesses that they felt ought to be incorporated because they were severe. Now, these weaknesses include both architectural and coding weaknesses. So some weaknesses are at the unit level. They are weaknesses that would appear in a single component, a single module, a single object or method, and they would be something that a programmer, a developer might detect using a unit test, although unit tests usually detect functional problems in the code, not necessarily structural problems in the code. And what we're dealing with in these measures are structural problems. So there are things at the single unit level. However, that single component deals with a lot of components at the same level of the application. So let's say that component's written in Java, it's interacting with a large collection of components and objects and modules and whatnot that are also written in Java, and they're far beyond anything that single developer will be looking at. And so we need to be able to detect faulty interactions between a number of the different components at that layer of the application. However, most applications are built from a technology stack. So we have a user interface layer, we've got the business logic, we've got some frameworks like Spring or Struts or Hibernate. We have data access layer, which allows us to go down into the database where we have the data stored. So there's a number of different levels of layers in this application. They're probably written in different languages. I mean, I may have JSP or ASP up at the user interface level. My business logic may be in .NET or Java, and so I go all the way down into the way that the languages use SQL and others for accessing the data. So any modern application probably has 4 or 5, maybe more different languages that the application is built in. And the problem here is that there may be faulty interactions among the components that sit in these different layers. So the most devastating weaknesses often involve multiple layers, multiple components spread across the application, and those are the hardest to detect. They take up almost half the maintenance effort, even though they rarely account for more than 10% of the weaknesses, and they account for a large proportion of the outages in the system. So the CISC measures look both at things that would occur at the individual component level, but also things that would occur across multiple levels, things that would involve, for instance, layer skipping calls that may avoid the proper data access mechanisms, or even possibly avoid some of the user authentication mechanisms that create security issues. So we have to be able to look at the whole application, and the CISC and measures, and now the ISO 5055 measures include weaknesses that are both architectural and coding. All of the weaknesses in ISO 55 are incorporated into the common weakness enumeration. Bob Martin at MITRE, who has been one of the senior people involved in the common weakness enumeration work, has worked very closely with CISC in helping build a number of these measures. And it's among the CISC, the 5055 measures are weaknesses are among the weaknesses now incorporated into the common weakness enumeration repository. Originally, the repository only housed weaknesses known to be exploited by hackers, so they were primarily security issues. However, several years ago, they made the decision to include severe weaknesses that affected almost any of the major quality characteristics, such as reliability or performance efficiency or maintainability. So the good news here is that this is an international standard. The Common Weakness Enumeration Repository is an ITU standard, International Telecommunications Union, which is recognized by the United Nations. So we've made a strong effort at to incorporate standards, both ISO standards and ITU standards, into the creation of these measures. So they are as close to international standards as we could possibly keep them. They're consistent with a number of international standards, one of which is the Common Weakness Enumeration. So each of the weaknesses in 5055 has a CWE identifier, a number that identifies its place in the Common Weakness Enumeration. What's an ISO 55 for users? For users, there's a description of the weaknesses. We give you the CWE number. We give you a simple title, a descriptor for the weakness, and there's a description of the weakness itself that gives you a fairly high level description of what's in the weakness. You can see that here are CWE 119 is the high level description of what a buffer overflow is, but then here's 4 of the 12 or 13 different instantiations of a buffer overflow. This shows you 4 of them, different ways that this can occur, different instances that would need to be detected by some form of static analysis technology. In addition, there's descriptions of the measures. The base measure for ISO 55 is a simple count of the weaknesses in each of these 4 quality characteristic areas. Now, you can create other measures from that. You can derive measures from the base measure, for instance, by dividing the base measure by size so that I get a density measure. Or I could create a sigma level measure. Is this at 2 sigma or 4 sigma, depending on the number of weaknesses per thousand or per million parts. So we can create a number of different derived measures. Some of these are suggested in the standard itself, but it does give you in the back a description of some of the measures. But the base measure is simply the count of weaknesses from which you can derive measures that are useful for various quality activities. Now, for developers, for the vendors of software static analysis technology, there's a number of sections that provide them the information they need to instantiate in their technology ways to go about detecting these weaknesses. So we have a formal description of the weakness, some of it represented in a pattern model that's an official standard with the object management group, and then a list of the detection patterns, different ways to detect that particular weakness. And then we have a section that provides all these detection patterns. It'll give you a descriptor of the pattern, and then you'll show you in what's called micro KDM. KDM is the knowledge discovery meta model. It's also an ISO standard that's a way to represent the elements that come out of a parse. So I parse the code, I represent all the elements that we pulled out of the parse, and what we show in the detection pattern is how those elements are organized to create that weakness. This is what you need to be able to detect the weakness, and then what gets reported once the weakness is detected. So this is available for the vendors of static analysis technology to use these descriptors to understand what they need to detect, to build the information you need from which to calculate the measures. There's two ways to obtain ISO 5055. One is you can go pay for it. It's 198 Swiss francs, and there you see on the left, you see the official ISO URL and website where that's located. However, ISO also provides that standard for free. Because it was a publicly available standard, it appears on their publicly available standards website, and you can go on that website, go look for ISO IEC 5055 colon 2021. You'll find it, and then you just click the EN, that stands for English, and it will give you the standard. Currently, the standard only appears in English. I suspect at some point it may be translated into some other languages, but you can go get a free copy of the standard and find all the 138 unique weaknesses that are captured in that standard and how they're organized into the 4 quality characteristic measures. This is the CISC website. You can also get the copy of the standard as it appears in its OMG instantiation from the website. But there's a lot of other information here. All of the standards that CISC has created, that OMG has accepted as OMG standards, are available both on the CISC website and the OMG website. We have almost 4,000 individual members. Membership is free. Our consortia is funded by sponsors, and we would love to have your organization as a sponsor of CISC to continue all the work we're doing on building international standards for measuring software. And we have new projects dealing with software bills of materials, with measures for DevOps and agile environments, with measures for model-based software engineering, and other kinds of areas of need for measuring software. And you can see we have all kinds of content available on the website, not only the standards, but contract language for building these kinds of standards into your contracts and service level agreements with your vendors. There's a trustworthy systems manifesto that lists 5 areas that we feel are critical for an executive to know that the software that's running their business is trustworthy, that they can depend on it. These are the process issues, they're product issues that need to be represented, need to be accounted for in the way software is built and deployed, in order to know that your business is not at risk from the software that you have in your applications. And we also have all the presentations for all the cybersecurity or cyber resilience summits that we've conducted over the last 6 or 7 years. And these are typically people that are senior industry people or senior government people talking about the actions they're taking to try to improve the reliability and security and dependability of software. We have tutorials, white papers. You can contribute to blogs. So there's a lot of things there. We're working on a meta model for process maturity because we've had some requests for that, and we've actually helped some other areas build maturity models relevant to their areas, such as we worked with the healthcare community to build a maturity model for healthcare. So, and we conduct annual cyber resilience summits. We conduct them annually in DC. We also have conducted them in Europe and in India. So we'll continue conducting those once the world is opened up from this horrid pandemic, in order for us to be able to travel and participate with folks in other countries. So that is the information about the new standard ISO IEC 5055, how it's constructed, how it's used, where you can get it, especially where you can get it for free. And so let me open in the last 5 minutes here. If we have some questions, let me open it up for questions. Let's see if I can get if there's any questions in the chat box here. Whoops. Okay, that didn't work well. Oh, no questions in the chat box. If you, Brian, if you want to unmute people, if they want to raise their hand and ask a question, I'll be happy to answer it.
Okay. We have one question. Someone asked if we could paste the link to the free version of the standard on the chat, and so that we'll include that when we send everyone the recording of the webinar. We'll include the link to the free version.
Yes, yeah, that was a fairly long URL.
Yeah.
I'll go back to
All right,
that.
are you seeing these questions coming in now? We have a few.
Do you see some more questions there?
Yep. So one is, what is the difference between 27001 and 5055?
Well, 5055 actually lists the weaknesses in software. 27000 tends to be a process-based standard, which is critical. But what 5055 adds to all of this is a list of severe weaknesses in the software related to security that need to be remediated, that need to be removed. So what this contributes is a measure of the security of the software itself, built from weaknesses detected in the software. So you need both. You need a process standard and you need a product standard.
Okay.
Next question.
Do you know if tools like SonarCube already have or plans to include this in their analysis?
I know that the two sponsors that are in the static analysis area both intend to provide this or already provide this in their technology, and that's Synopsys and Cast. So I know both of those will have that available in their technology and are work. If they're working on it, they have most of the weaknesses already detected, and they're adding the last few. I suspect they're not the only ones, frankly, ultimately, that will incorporate these, but I know as sponsors, I know they've committed to doing it.
Okay. Another question is, apart from static analysis that Anders mentioned, how do you see the standard being used in a small business that builds software?
Well, a small business, in fact, regardless of the size of the business, if you're building software, you want to know that it's secure, that it's reliable, that you can maintain it without excessive cost, that its performance won't degrade. So anyone building software would want to use some form of static analysis technology to make sure that the internal structure of the software is secure and reliable and maintainable and what have you. So I don't. The size of the company wouldn't matter. It's the fact that you're building software and want to make sure that what you deliver for your own use or for a customer's use has these attributes. It's reliable, it's secure, its performance won't degrade, and it's maintainable. And so it can be just as easily used by a small or medium-sized enterprise as by a large one.
Mm-hmm. All right. One other question is, are ISO 25010 and 5055 supposed to be used together?
They can be, yes. 25010 simply describes the quality model. It's being revised to update it, and there's some excellent work being done to update it, to modernize software, and to some areas of embedded software like safety. But it simply provides a quality model. This should be used in conjunction with 25023, which defines measures of these various quality characteristics, mostly at the behavioral level. There are some measures at the software level, but primarily it looks at the behavior of the software once it's in operation as a way to measure these characteristics. Whereas 5055 measures them in the software itself. So they supplement, 5055 supplements 25023 by providing product level measures, internal structural measures of the software prior to it being put into operation. So it should be used jointly with 25023, and both of them are based on 25010.
Mm-hmm. Right. Yeah, all the
One
questions
final
are coming in
question,
now.
maybe?
Sorry, what was that?
Is there a final question?
Oh, yeah, we'll do one more. Let's see. Is there any relationship with the HIS metrics?
The HIS metrics. I'm not sure what those are.
Okay. All right, then I'll do one
I've got
more.
lots of measures in my head, PSM measures, DORA measures, object-oriented measures. So I'm not sure exactly which set those are. If they represent weaknesses in the software, if they're built from detecting weaknesses, then yes, they would be related. If they're primarily measures of things like object characteristics, yes, we have those. Some of those are weaknesses. Having too many child metrics under a child objects under a parent object, that would be a weakness. So there are some that are related to the classic object-oriented measures that deal especially with the maintainability of software. So there are some measures like that we are related to. But they would need to be measures that are actually taken from the software itself. So with that, let me thank you for attending the webinar. We're going to close it now. We will, to everyone who has registered, we'll send out a copy of the slides, and we'll list that URL so that you can access the free copy. And with that, thank you for attending, and good day.
All right. Thank you.
Thank you, Brian.